Hello. In this video, we're going to continue studying our exponential equations, but we're going to add some more twists to the questions. To do that, we need to look at roots. So if you take a look at the square root of 3 and 3 squared and the cube root of 3, these all seem kind of different, but they all feel kind of the same. They're all 3's, right? But how do you compare a 3 squared with a root 3 and even a cube root of 3? How do these all connect to one another? What we need to remember is that square roots, and really, I could say really all roots are also exponents. If someone gives you the square root of 3, you can rewrite that as 3 to the 1/2. If someone gives you the cube root of 3, you can write that as 3 to the 1/3. Heck, if someone gave you the square root, or let's say the fourth root of 3 to the 5, you could write that as 3 to the 5/4. The rule for roots are whatever number is here on the root becomes the denominator. It's sometimes easier on a cube root because that 3 becomes the denominator of 3. The tricky thing sometimes is a square root, because a square root sort of has an invisible 2 right here. A square root, we don't write 2, but the square root is technically like the second root, right? The cube root is like the third root. And so that 2 that we have there becomes the denominator. And then every exponent just becomes the numerator. So the 5 that we have here becomes the numerator. The invisible 1 that we have here becomes the 1 over there. The invisible 1 we have here becomes the 1 over there. And the 3 squared just stays as a 3 squared. And so writing roots as exponents is really, really helpful. In fact, what the roots get written as is fraction exponents. They're exponents, but they're exponents with fractions. Now, we have the same base, so we can go ahead and add the exponents. We'll get 1/2 plus 2 plus 1/3. Now, you might not like adding fractions, but what this allows us to do is take 3 different powers of 3 and combine them all into a single power of 3. It's just that the math is a little messy, so I'm going to do this as an aside. 1/2 plus 2 plus 1/3. We're going to go for a denominator of 6. So times 3 times 6 times 2. So that'll give us 3 plus 12 plus 2 over 6, which will be 15, 16, 17. 17 over 6. So this is 3 to the 17 over 6. That's like the simplified or the compact way of writing root 3 times 3 squared times the cube root of 3. It's 3 to the 17 over 6. Now you might say, well, Mr. Peters, why am I going to bother rewriting powers of 3? It was fine the way we had it. This looks super messy. And I might say, sure, writing all the powers of 3 compacted might not be useful just sort of randomly, but I think you're going to find it pretty useful in the next question. So here we have 5 to the 2x equals 125 times root 5. Now 125 is 5 cubed. So we could write this as 5 cubed, root 5, 5 to the 2x. And it might be tempting to drop the base. We have a base of 5, drop the base, but this is still sitting here. We can only drop the base when that's all you have left. You can't have extra coefficients, you can't have extra terms. It has to be exactly like 5 to the stuff equals 5 to some other stuff. That's the only way you can drop the base. If you have things here, things divided, it's not okay. It has to be just a 5. And so this root of 5 is messing it up. We need to find a way to take that root 5 and combine it with the 5 cubed. But again, those exponents to the rescue. Root 5 is the same as 5 to the 1/2. So we can write this as 5 cubed times 5 to the 1/2, which is 5 to the 3 plus 1/2. Now again, as an aside, you might need to do a little bit of fraction work. How do you add 3.5? Well, you make this over 1, multiply by 2, so 6 plus 1 over 2, so 7 over 2. So you'll have 5 to the 7 over 2 equals, got to keep writing that left-hand side, 5 to the 2x, 5 to the 2x. So that's going to give you 2x equals 7 over 2. Now we can drop the base. Divide by 2, and x equals 7 over 4. So again, it's really, really important that when we see those square roots or cube roots, we rewrite them as an exponent. All right, go ahead and pause the video and give this one a try. I'll give you a hint. 4 cubed is 64. All right, so we have 4x equals the cube root of 4 cubed times 4 to the 2x plus 1. We can rewrite the cube root as 4 to the 3 over 3 times 4 to the 2x plus 1. This is actually kind of nice because 3 over 3 will just be 1. So this is 4 to the 1, 4 to the 2x plus 1. Now we can add the exponents, so 4 to the 2x plus 2, just adding those ones together to make 2. Now we can drop the base, 2x plus 2, move the x over, move the 2 over, and we get negative 2 equals x. All right, this one looks a little tough. We've got all the 12s already, but they're not combined into a single base. So pause the video and give it a try. Okay, 12 to the 2x minus 1, 12 to the x over 4, 12 to the 2. 12 to the 2x minus 1 equals 12 to the x over 4 plus 2. So you might want to do that on the side. Put it over 1 times 4 times 4. So x plus 8 over 4. So 12 to the x plus 8 over 4 equals 12 to the 2x minus 1. Drop the base. And here's where the algebra is a little nasty. So I would recommend we clear the 4 by multiplying both sides by 4. You don't have to, but this is probably the nicest way to do it. This will give you 8x minus 4 equals x plus 8. Sneak that x over to get 7x. Sneak the 4 over to get 12. And x equals 12 over 7. Again, if you like algebra, these questions are kind of fun. They're sort of like little puzzles to get the algebra set up. And then once you drop the base, you get to do a little bit of algebra in the end. Okay, 10 times 2 to the 2x minus 3 equals 80. This one is weird because if you try to take 10, you're not going to get a power of 2. And if you think about 80, I mean, that's not a power. 81 is a power of 3, but 80 is not a power of 3. And so the way it looks, I don't know what to do. But here's the little trick. Let's divide both sides by 10. If we do that, we get 2 to the 2x minus 3 equals 8. And now 8 is a power of 2. 8 is 2 cubed. All right, you can probably finish it off from there. But just in case, I'll show you. This is 2 cubed. Drop the base. Move over the 3, and x equals 3. So a little trick right there. You're more than welcome to multiply or divide if there's kind of like coefficients in front, especially if those coefficients aren't powers of 2 or powers of what you're looking for. All right, this one looks pretty tough. We're clearly going to go for powers of 3, but it looks like it's going to be a tough road. So pause the video and see how far you get. All right, so 3 to the x squared. 9 we'll write as 3 squared, and then power of 10x. This will be 3 to the negative 1. 9, we could actually square root it. It's just a 3, so 3 to the 1. And the 27, I think I'm going to subtract these first to be 27 to the 14. So that'll be 3x squared, 3 to the 20x, 3 to the negative 1 equals 3 to the 1 times 3 to the 3 to the 14. That's going to be 3 times 14 is 42. 3 to the x squared plus 20x minus 1. Okay, so this is 3 to the 43 equals 3 to, oh, what a monster, x squared plus 20x minus 1. Okay, let's drop the base and focus on the algebra. 20x minus 1 equals 43. We're going to have to move everything to the left because this is a quadratic, so x squared plus 20x minus 44. Looking for two numbers that multiply to give negative 44 and add to give 20. I'm thinking 22 and negative 2. Yep. So x plus 22, x minus 2, x equals negative 22, and x equals 2. All right, so this actually has two solutions because there was a quadratic involved in the algebra. A lot of extra fun there. But as long as you just follow the steps, you should be good to go. All right, here's another one. We've got 3 to the 2x minus 12, 3 to the x plus 27 equals 0. This is a bit of a strange one, and there's not a lot like this. But just so you know, I do want to show you one of these. Because of the minus and the plus, we can't actually use exponent rules on this because exponent rules only work when you have multiplication and division, not addition and subtraction. So for this question, we actually have to kind of undo the exponent rule. 3 to the 2x is the same as 3 to the x squared because x times 2 is 2x. Then we have a 12 times 3 to the x, and then we have a 27 equals 0. So what we have sort of is like x squared minus 12x plus 27. So this is actually like a secret quadratic. If we let y equal to 3 to the power of x, we get y squared minus 12y plus 27 equals 0. You might remember solving these types of things with the trig equations. A clever substitution allows us to turn a weird equation into a quadratic. Now from here, we just need two numbers that will multiply to give 27 and add to give negative 12. I'm thinking negative 3 and negative 9 look pretty good. So y minus 3, y minus 9 equals 0. So y equals 3, y equals 9. But remember, y was equal to 3 to the x, and we're trying to solve for x. So substitute back, 3 to the x equals 3, and 3 to the x equals 9. In other words, we're now back in our exponent land. We can drop the base. This means x equals 1. Obviously, 3 to the x equals 3. I mean, you can kind of just guess and check, right? X has to equal 1. This one's a little trickier. This will be 9 is 3 squared. So x equals 2. But again, I think you could see that. What power of x do you need to, or what value of x do you need for 3 to the x to equal 9? Yeah, 2. 3 squared is 9. Now, again, like I said, this isn't the most common problem, but if you do see something where you've got addition and subtraction, you can't use exponent rules, so you do have to do something clever like a substitution like this. All right, so again, we're still solving exponential equations. Solving exponential equations. And the main tools that we learned today were that if you had the cube root of 4 to the 5, that's going to be 4 to the 5 over 3. We need to convert those into exponents so we can continue to work on them with our regular rules. Here we have an example over on the left, and the answer should be 8 over 9. If you want, you could try another one from Unit 8, Worksheet 3. And then you can write down any things to remember. All right, hopefully you enjoyed this video, and as always, thanks for watching.